In the vast universe, differences in density between gas giants and terrestrial planets. There seems to be a great mystery hidden behind it. The Earth is our home for survival. It is also the beginning of our understanding of planets. Yet the universe is so vast. Beyond Earth, there are all kinds of amazing planets. Differences in density between gas giants and terrestrial planets. After the Earth, the known planets, in order of size. Non-terrestrial planet. Because they contain a lot of hydrogen and harmful gases. That's why Earth-like planets in the solar system. The density is about 5 times as many gas planets. Apparently these two types of planets. There's a huge difference in size. But is this the universe? In class, the best options available in terms of planet size. Can they get bigger? Have we found such a planet? These issues will be explored in this video. Sir GG 1719 1438b. A white dwarf star turned into a diamond planet. This is a Sir GG 1719. Planet 1438b. 4,000 light years away. The density is about 23 grams per cubic centimeter. That's 4 times the size of the Earth. About 20 times the size of Jupiter. But its mass is similar to that of Jupiter. Make it 30 to 300 times heavier than the Earth. Its diameter is estimated to be about 4 times that of the Earth. Similar to Neptune. Considering the high density, this planet is definitely not a gas giant. Although its density is comparable to that of a brown dwarf. But it's not a brown dwarf either, because its quality doesn't even reach brown, the minimum mass of a dwarf star, and 13 times the mass of Jupiter. Therefore, although this planet is not a gas giant, or brown dwarf, calling it an Earth-like planet is a bit misleading, because it has a much greater surface gravity than Earth. This means that it is difficult for gas to escape from the surface. Surface pressure may easily 10,000 times the size of Earth. Even so, huge atmospheric pressure will not affect the overall density of the planet, make it resemble a gas giant planet. Although there are indications of tremendous surface pressure, but if the solid surface is low enough, then this planet, it can be considered as completely teary. If not now, maybe in the future. The planet orbits a diameter of about 20 kilometers, with a mass about 1.4 times that of the Sun. Type neutron star orbit. The distance is about twice the distance from the Moon to the Earth. He completes a revolution every 2 hours and 10 minutes. He was able to do this without being swallowed by the star, because he's orbiting a typical neutron star. So because the planet is close to the star, it is likely to have a very hot surface. This means that atmospheric molecules are polar, move at high speed. This could, over a long enough period of time, lead to significant atmospheric escape. In addition, due to the very close orbital distance, he may also be affected by the strong solar wind, enough to keep the atmosphere decreasing. However, the strength of the solar wind, and whether very high temperatures can be overcome. Extremely strong surface gravity. It's hard to say that most of the atmosphere will disappear. In addition, the planet may also have a magnetic field. The atmosphere has been protected to some extent. Protection from the solar wind. So this planet might only be semi-Earth-like. Means he may have a solid surface, but also surrounded by the atmosphere that follows. However, there are also some problems with calling him that, because the surface may not be solid. He may have a global lava ocean, or a global ocean of liquid carbon. Because the surface may be due to very close to a neutron star, it gets really hot. Considering that the planet is mainly composed of compressed carbon, there may also be carbon on the surface. This carbon may be in a liquid state due to for carbon at about 180 and starts to become liquid at 4,200 degrees Celsius. According to the same carbon, 18 is equal to the surface pressure on the Earth. Obviously, carbon remains liquid at high enough temperatures, until about 1,008,000. Therefore, considering that this planet, it can have a very thick atmosphere, and the surface temperature is high enough, could allow for a global ocean of liquid carbon, that would make the planet not even semi-Earth-like, due to the lack of solid ground. Found this. Planetary researchers published their findings in 2011, estimated the mass of the planet, and estimated his diameter from its orbital properties. They believe that this planet is actually the core of a star. It could be a white dwarf star that has lost its outer layer, leaving behind a core rich in carbon, nucleus, and oxygen. Researchers say carbon is crystalline, so there may indeed be a lot of diamonds. Kepler 277b and Kepler 277c planets. Diameters of Kepler 277b and the Kepler 277 system. About 3 times the size of the Earth. Although they may be completely similar, but it's also possible that they are only half-class, means there may be solid ground, but surrounded by gas. Surface pressure over 18,000. These two planets, around a mass similar to the Sun, but a star twice the diameter of the Sun orbits, and they're both closer to the Sun than Mercury. The surface temperatures of these two planets are likely to be at least as high as Venus is similar, very hot, probably more heat, and there may be global lava oceans. Such a close orbital distance. It also means that the solar wind can be very strong, so the atmosphere may often be blown away. However, that may not be enough to finish them off. All turned into teardrop planets, because they have a good chance of having powerful magnetic field. Large planets usually have. This can largely safeguard, protect them from the solar wind. In addition, both planets have extremely strong surface gravity. This would also greatly prevent the escape of the atmosphere, even at very high temperatures. The surface gravity of 277b is about 10 times that of Earth. It's about 90 times the mass of the Earth. Similar to Beryl star. The surface gravity of another planet, System 277, that's about 6 times the size of the Earth, 60 times the mass of the Earth. Its density is about 9 grams per cubic centimeter, twice the size of the Earth, but it's also half the size of 277b. Indicates that this planet is larger than 277b, more likely semi-terrestrial, because surface pressure may easily over 18,000. A lot. Are there completely Earth-like planets? How do we determine the density of an alien planet? We can say this. They are completely analogous. It's like the Earth, but the diameter is several times that of the Earth. There are no known planets like this yet, but what is known is that the more massive the planet is, the harder it is for him to escape the atmosphere, and greater mass correlates with size. Therefore, a bigger planet is less likely to be tearful. A study found that most planets 1.6 times the size of Earth, not rocky, means most planets over 20,000 kilometers in diameter are surrounded by gas. Over that size, the density of planets is rapidly decreasing because they have enough gravity, largely captured gas. Even hydrogen gas in a circular disk can't escape from the extreme gravity, and there are planets and terrestrials in a gaseous state. Stages between planets. So how do we know the outside world? What about the density of stars and planets? Density is mass, no doubt volume. So knowing the diameter and mass of a planet, it can also reveal its density. So how do we know? What about the size and mass of an alien planet? A simple and easy to understand method is when an alien planet is destroyed in 2 ways. When detected, 1 is piecemeal. When a planet passes in front of a star, cause the star to dim. This reveals the diameter of a planet. The second is the swing method. By detecting a planet, the pulling force of the host star, to reveal the mass of the planet. There are other ways to find an alien, the size of the planet, and estimate its mass. Although in many cases, Density can be determined fairly accurately, but that doesn't tell us about an alien planet. Is it surrounded by gas? He only told us if he was a gas giant, because even a very dense planet, it is still possible to compare it to the Earth. Huge surface pressure, and that still doesn't affect the overall density. Make it similar to gaseous going to planets. For example, the surface atmospheric pressure of 277b might be 18,000, and this atmosphere, probably only about 0.01% of the planet's total mass. Given the very strong surface gravity, he may not extend to much either. Therefore, knowing the density of a planet does not allow us to accurately distinguish a complete classification. In semi-terrestrial planets, LHS 3844b TB, completely terrestrial planets are larger than Earth. So before looking for fully terrestrial planets, we first need to define what he is. Now, start with one that can be defined. Included examples to start with. That is, there is no atmosphere or atmospheric pressure. Planet's roughly the same as Earth, and it has a solid surface. It's exactly like Earth. This classification is widely accepted in the astronomical community. Before this point, one of the largest known planets, its atmospheric pressure is likely to be less than 18. LHS 3844b. It's 16,500 kilometers in diameter, much larger than the Earth. He is closer to us. The distance is 48 light-years. He's orbiting a red dwarf star. That's twice the distance from the Moon to the Earth. And he did it in 11 hours. A complete orbit. The planet was set to face west. Means that one side is always far from the host star, due to the lack of a thick enough atmosphere. This is why always stay away from constant. The temperature on that side of the star may be below the freezing point of water, so it's freezing out there. It always faces red. The temperature on that side of the dwarf star is estimated to be about 800 degrees centigrade. Between the sides, the reason for such a large disparity is that not enough atmosphere, heat from the daytime side, reassigned to the night side. So this planet is probably teardrop, especially on the side where it's always night. One of the largest known planets. It may not have a very thick atmosphere. It's the arm of Trapeze, 40 light-years away. This planet is almost as dense as the Earth. Exactly the same. The conclusion about the lack of a very thick atmosphere. It's from James Webb, the telescope's view of the planet, derived from the test. It also reveals that the planet is quite dark. Although the diameter of Telepis is 14,200 kilometers, it's not much bigger than the Earth, but considering that he may lack a significant atmosphere, the surface temperature is estimated to be around 230 degrees Celsius. So, all the extraterrestrials mentioned in this video, in the planet, this planet appears to be the coldest overall, so there's probably no lava ocean. The system in which this planet resides is also quite interesting. It orbits a plane wider than the Sun, and cool red dwarfs with 10% less mass is in this system the closest planet to its host star. The system consists of a total of 7 planets. This IPC1 ratio complete a complete orbit every 36 hours. And the distance he orbits the infrared star, only 4 times farther than the Moon is from the Earth. As research on alien planets continues, it is very likely that larger Earth-like planets will eventually be discovered. They don't have thick atmospheres, have solid ground. Is to judge a planet, can it be considered a fully terrestrial planet? Very important basis. But as a complete classification, what is the upper limit of surface pressure? A surface pressure of less than 18,000 seems fairly reasonable. 18,000 is 10,000 times the Earth's surface pressure, 100 times the surface pressure of Venus, 10 times the pressure at the bottom of the Mariana Trench. This is 11 kilometers of water. This pressure cutoff seems fairly reasonable. Can distinguish one end holomorphic and a semi-terrestrial planet. Considering that even Venus, its surface pressure is 98. The atmosphere near its surface is also on the verge of boundary fluid state. This means that although it is like a gas, but it also behaves like a liquid due to the tremendous pressure. Therefore, if the pressure of a planet more than 100 times the surface pressure of Venus, it seems fitting to call it a semi-terrestrial planet. The size limit of a fully terrestrial planet is unknown, although most planets over 20,000 kilometers in diameter, it's not terrestrial, but there may be some extreme outliers, may give rise to an Earth-like planet the size of Jupiter, but we don't know for sure yet. Does it exist? Or will exist? This is the first one discovered by humans. From stars and gas giants, a giant, completely Earth-like planet formed. HD 209458b, planet orbiting a neutron star. It seems that it used to be lost most of its outer white dwarf. Because the neutron star carried it away, planets formed like this. After a long enough time, it could eventually lose its entire atmosphere, leaving behind giant airless teardrop planets. So there's these giant teardrops, a way for planets to form. Maybe they can also form from gaseous planets. Gaseous planets have rocky cores. As mentioned, they started out as large, rocky planets, then start trapping gas. Jupiter. It is estimated that there is a core much larger than the Earth. A gas giant could be lost. The manner of its atmosphere is, for example, if he doesn't have a strong magnetic field, then he came very close to his host star. Extreme heating can cause atmospheric molecules reach escape velocity on a large scale, eventually leaving behind an airless planet. Then there might be an ocean of lava on the surface. Because of the exposed rock core, surfaces can become liquid due to extreme temperatures. However, the same line, the orbit of the star may begin to move slowly and further away from its host star. Ultimately, the surface solidifies completely because the temperature drops. This will create a huge, completely Earth-like planet, although this may be an extremely rare scenario. But he seemed to have a chance. It could happen around a red dwarf star. He could last for hundreds of millions of years. Enough time for the atmosphere to be glassed. There's another known example of a gaseous planet. It is estimated that he is actively losing every second millions of tons of hydrogen, and that's HD 209458b. He orbits his host star so close, so much so that the huge heating causes the atmosphere to extend greatly. That's why, although it is about 0.7 times the mass of Jupiter, it's also 1.4 times the diameter of Jupiter, so it's less dense. However, he may not take it. The former loss velocity becomes a teardrop planet. It would take him billions of years to lose its hydrogen content. Heavier gas. It may take longer. Even if the process sped up, he still might not turn into a teardrop planet. This planet, orbiting a main sequence star similar to the Sun, that star, it could become a red giant in a few 100 million years. Zhejiang caused the planet to be swallowed. Because of the distance he orbits his host star, only 7 million kilometers, closer to the Sun than Mercury, so even as the orbits of the planets expand massively, can't save it. If he somehow, before being devoured and destroyed, lost the atmosphere, surface temperature, it doesn't allow for solid surfaces. Although this is not a gaseous planet to go to, the case for turning into a teardrop planet, but such a situation has been outlined, may happen, although it may be extremely rare, but he seemed possible. There could be other ways, so that giant teardrop planets could form, considering that there are such things in the observable universe. So many planets. Likely among these planets, at least one of them has a diameter that's the back of the Earth, and it has a solid surface. An atmospheric pressure comparable to that of the Earth means complete teardrop, maybe even a planet the size of Jupiter, although it has not been found yet. but it may be discovered in the future. For now, limited to observational means, and we can only speculate about them. Thanks for watching. Welcome to Mink Brigade to leave a message to find fault.